Walk through any boat show today, and you'll see sailboats that look nothing like the vessels that crossed oceans and weathered storms for generations. The modern sailboat gleams with frameless windows, touch-screen displays, and open-plan interiors that look like floating condominiums, rather than seaworthy craft designed to handle what the ocean throws at them. The builders market these features as innovations, selling buyers on convenience and style, while quietly sacrificing the durability, simplicity, and seaworthiness that made classic sailboats valuable decades after they were built. But here's what the glossy brochures don't mention. These modern features are destroying resale values, creating maintenance nightmares, and building boats that seasoned sailors won't touch at any price. Survey the used sailboat market, and you'll find a disturbing pattern. The sleek modern boats with all the latest features sit unsold for months or years, while buyers chase older designs built when manufacturers prioritized ocean-worthiness over boat show appeal. Here's what most buyers missed while being dazzled by features that look impressive at the dock, but become liabilities the moment you leave protected waters. This isn't progress. This is an industry that forgot what sailboats are actually for, building vessels that photograph well but sail poorly, that impress neighbors but terrify offshore, and that lose value faster than the financing used to buy them. Number 12, excessive luxury fit-outs. The 12th problem ruining modern sailboats is excessive luxury fit-outs that add weight, cost, complexity, and depreciation while reducing the functionality that makes sailboats valuable. Modern manufacturers load boats with air conditioning, generators, water makers, washing machines, and other systems that turn sailboats into floating condominiums. The weight implications are staggering. These systems can add thousands of pounds to displacement, raising the waterline, reducing freeboard, and degrading sailing performance that buyers purchase the boat to experience. The electrical demands require massive battery banks, large alternators or generators, and complex charging systems that create failure points throughout the boat. The generators add hundreds of pounds more, along with fuel tanks, exhaust systems, and soundproofing that all contribute to making the boat heavier and less responsive under sail. Own a modern sailboat with features that seemed great at the dock but haunt you at sea? Watched your resale value tank because of frameless windows or digital switching? Share your story in the comments. Subscribe now. We're exposing the truth about what really makes sailboats last, and you don't want to miss what's next. The maintenance requirements for luxury systems are substantial and ongoing. Air conditioning systems need regular service, with compressors that fail, refrigerant that leaks, and condensate drains that clog. Refrigeration requires constant attention, with evaporator plates that frost over, compressors that cycle constantly, and electrical draws that drain batteries faster than charging systems can replenish them. The air conditioning compressors operate in harsh marine environments, where saltwater corrosion attacks electrical connections, moisture infiltrates sealed components, and constant vibration from the boat's motion loosens fittings and creates leak paths that allow expensive refrigerant to escape slowly. The condensate water produced when air conditioning removes humidity from cabin air must drain overboard through small tubes that clog with algae, mold, and mineral deposits, causing water to back up and overflow into bilges, or drip onto expensive teak sole and cabinetry, where it creates staining and rot. The refrigerant lines, running from compressors to evaporators and condensers, are vulnerable to vibration fatigue, developing cracks at joints and fittings that require specialized equipment to detect and repair, often necessitating complete system evacuation and recharging at costs of hundreds of dollars. The electrical components controlling air conditioning systems include thermostats, relays, and circuit boards that corrode in the salty, humid marine environment despite being mounted in supposedly protected locations, failing unpredictably and requiring replacement with parts that may no longer be available for systems more than 5 years old. The refrigeration systems suffer similar problems with added complexity from the need to maintain much lower temperatures than air conditioning requires, creating frost buildup on evaporator plates that reduces efficiency and eventually requires manual defrosting that interrupts food storage and creates inconvenience during extended cruising. The compressors cycling on and off constantly to maintain refrigeration temperatures create electrical loads that can drain a 400 amp-hour battery bank completely overnight if charging systems aren't keeping up, leaving the boat without power to start engines or operate critical systems in the morning. The holding plate systems that some boats use for refrigeration require running engines or generators for hours daily to freeze the plates, consuming fuel and creating noise that destroys the peaceful anchorage experience that many cruisers seek when they escape to remote locations. The water makers that produce fresh water from seawater are perhaps the most maintenance-intensive luxury system, requiring the reverse osmosis membranes to be pickled with chemical preservatives whenever the system sits unused for more than 3 days, or the membranes will foul and lose efficiency permanently. The high-pressure pumps that force seawater through reverse osmosis membranes at pressures exceeding 800 pounds per square inch require regular seal replacement, with the seals degrading from constant exposure to salt water and the abrasive particles that pre-filters cannot completely remove. The pre-filters themselves require changing every few weeks during active use, with replacement cartridges costing $20 to $30 each, and the labor of changing them requiring shutdown of the entire system and careful attention to avoid introducing air bubbles that can damage the high-pressure pump. The product water quality must be monitored constantly using TDS meters or total dissolved solids meters that measure the effectiveness of the desalination process and warn when membranes are failing and allowing too much salt through, requiring immediate shutdown to prevent damage. The electrical consumption of water makers is substantial, with typical systems drawing 20 to 30 amps continuously during operation and requiring running for 1 to 2 hours to produce enough water for a day's consumption, adding significant load to already stressed electrical systems. The washing machines that some luxury cruising boats feature consume enormous quantities of both water and electricity, with each load using 20 to 30 gallons of fresh water that must be carried in tanks or produced by water makers, and electrical draws exceeding 10 amps for cycles lasting an hour or more. The complexity multiplies when all these systems are operating simultaneously. Air conditioning drawing 15 amps, refrigeration cycling on for 8 amps, water maker running at 25 amps, and battery charger trying to replenish batteries at 50 amps creates total loads exceeding 100 amps that require generators running continuously, or enormous solar panel arrays that cost tens of thousands to install and maintain. The net result is that boats equipped with full luxury systems become dependent on running generators multiple hours daily, consuming fuel at rates of 1 to 2 gallons per hour, and creating noise, heat, and exhaust that contradict the peaceful cruising experience that sailboats are supposed to provide compared to powerboats that accept these compromises as necessary. The complexity means that failures cascade throughout interconnected systems. When the generator fails, you lose air conditioning, refrigeration, and the ability to charge batteries adequately to power all the other systems that luxury boats depend on. The water maker stops working without the generator to power it. The entire luxury lifestyle that the boat promised collapses when a single component fails, creating situations where the boat becomes genuinely uncomfortable or even unlivable until expensive repairs restore functionality. The depreciation is brutal because luxury systems age poorly compared to the basic sailboat underneath them. A 10-year-old air conditioning system isn't a valuable feature. It's a liability that buyers assume will need replacement soon at costs of thousands of dollars. The boats equipped with every luxury feature lose value faster than simpler boats because buyers recognize that complexity creates costs rather than value once the initial appeal fades and reality of ownership sets in. Number 11. Fixed swim platforms. The 11th feature destroying modern sailboats is fixed swim platforms that look attractive and function well at anchor, but compromise seaworthiness and create dangers when underway, in conditions that blue water boats were designed to handle. Traditional sailboat sterns were designed to shed following seas, with configurations that allowed waves approaching from astern to pass under and around the hull without pooping the boat or flooding the cockpit in ways that could be genuinely dangerous. Fixed swim platforms extend the stern horizontally, creating a platform that's wonderful for swimming at anchor, but becomes a liability when waves are running from astern. The platform catches following seas, creating resistance that slows the boat and risks having waves break over the stern and flood the cockpit, a genuinely dangerous situation that can swamp a boat or worse if the cockpit drains cannot keep up with water volume. The platforms act like scoops when waves approach from behind, gathering water that should flow harmlessly past and directing it into the cockpit, where it adds weight and creates hazards that can overwhelm drainage systems designed for normal spray and rain rather than solid water from breaking waves. The repeated flooding can damage electrical systems, drench gear that should stay dry, and in extreme cases fill the cockpit faster than drains can clear it, creating the terrifying situation where water pours below through companionway openings and threatens to sink the boat from accumulated weight that compromises stability and buoyancy. The structural implications are equally concerning because the fixed platforms add weight and windage at the absolute worst location, as far aft as possible, where they increase pitching moment and make the boat more uncomfortable in head seas. The platforms also catch wind when sailing, creating additional resistance and a weather helm that makes the boat harder to control and less efficient under sail. The platforms also complicate docking and maneuvering in tight spaces where the extended stern makes the boat effectively longer than its rated length and creates clearance issues that boats without platforms don't experience. The platforms are vulnerable to impact damage during docking mishaps, with repairs that can be expensive because the platforms are often integrated into the hull structure rather than being simple bolt-on accessories. The used boat buyers who actually sail offshore, rather than just day sailing in protected waters, see fixed swim platforms and recognize them as features that prioritize comfort over seaworthiness. The resale market reflects this understanding, with offshore-capable boats without platforms holding their value better than platform-equipped boats that appeal to a narrower market of buyers who plan to stay in protected waters. Number 10. Shallow bilges. The 10th mistake ruining modern sailboats is shallow bilges that reduce the water capacity and safety margin that deep bilges provided in traditional designs that prioritize seaworthiness over interior volume. The bilge is the lowest part of the interior where water accumulates from rain, spray, minor leaks, and the inevitable moisture that every boat experiences, regardless of how well maintained it is. Traditional designs feature deep bilges that could hold substantial water, 50 gallons or more on a 40-foot sailboat, providing time to identify and address the source of water before it became a serious problem threatening the boat's safety. The deep bilges also lowered the center of gravity, improving stability and providing a reservoir that bilge pumps could draw from efficiently without losing prime or cavitating. The deep sump areas allowed water to collect in specific locations, where pumps could be positioned to remove it effectively, keeping the rest of the bilge relatively dry. Modern designs sacrifice bilge depth to maximize interior volume, creating shallow bilges that hold minimal water and provide little safety margin if the boat begins taking on water from any source. The shallow bilges mean that even modest water intrusion quickly spreads throughout the cabin sole, creating the alarming sensation that the boat is flooding when the actual water volume might be minimal if it could accumulate in a proper bilge sump. The shallow bilges also make bilge pumps less effective because pumps cannot draw water efficiently from the thin layer that shallow bilges create, leaving substantial water aboard even when pumps are running continuously. The float switches that activate automatic bilge pumps cannot be positioned low enough to trigger when water first appears, meaning water levels must rise substantially before pumps activate and begin removing water. Number 9. Minimal handholds. The 9th problem ruining modern sailboats is minimal handholds sacrificed for sleek interior styling that looks clean and modern, but becomes dangerous when the boat is moving in seaways that anyone venturing offshore will inevitably encounter. Traditional sailboat interiors featured grab rails, handles, and structural elements everywhere because designers understood that boats move violently and unpredictably, requiring crew to maintain 3 points of contact while moving through the cabin to avoid being thrown and injured. The handholds weren't afterthoughts. They were integrated into the design from the beginning, positioned where they'd be needed based on how crew would move through the boat, and strong enough to support a person's full weight when the boat lurched unexpectedly. Modern interiors eliminate handholds to create the clean lines and uncluttered appearance that photographs well and impresses boat show attendees who never experienced the boat underway in challenging conditions where handholds become essential safety equipment. The marketing materials show couples moving gracefully through spacious interiors, but the reality offshore is that moving without adequate handholds becomes genuinely dangerous when the boat is heeling 20 degrees and pitching through waves that arrive irregularly and catch crew off balance. Crew members get thrown across cabins, suffering injuries that range from bruises to broken bones when they're unable to arrest their motion during sudden lurches that happen without warning when sailing in rough conditions. A crew member with a broken wrist or dislocated shoulder becomes a liability rather than an asset, reducing the boat's capability when it matters most. The lack of handholds is particularly dangerous for older sailors or anyone with mobility limitations who depend on secure grips to move safely even in calm conditions and absolutely require them when the boat is moving unpredictably. Designers creating interiors without adequate handholds are ignoring the realities of who actually buys and sails these boats. Number 8. Integrated touchscreen navigation. The 8th disaster ruining modern sailboats is integrated touchscreen navigation that looks impressively modern, but quickly becomes obsolete, expensive to replace, and potentially unreliable precisely when you need it most, during challenging passages or emergency situations. Traditional navigation instruments were modular, separate depth sounder, GPS, radar, and chart plotter that could be maintained, upgraded, or replaced individually as needed or as technology improved at its relentless pace. The systems used industry-standard connections and protocols, making it possible to mix components from different manufacturers and replace individual pieces without replacing the entire system when one component failed or became obsolete. The modularity meant that failures were isolated. When the depth sounder failed, you lost depth information but maintained GPS, radar, and chart plotting capability. Modern integrated systems replace all of this with single large touchscreen displays that control navigation, vessel systems, and entertainment through complex software interfaces that look impressive at boat shows, but create multiple problems for owners who actually use their boats for extended cruising. The integration means everything runs through one display. Lose that display, and you've lost all navigation capabilities unless you have complete backup systems installed separately. The problems are multiple and serious, starting with obsolescence that arrives faster than boats depreciate. The integrated systems become obsolete within 5 to 7 years as software updates stop. Charts can no longer be updated to reflect changing navigation hazards, and hardware capabilities fall behind current technology. Replacing these systems costs thousands or even tens of thousands of dollars, depending on the integration complexity and boat size, and replacement often requires extensive rewiring because the integrated systems use proprietary connections that aren't compatible with replacement units. The labor costs for rewiring can exceed the equipment costs. The reliability concerns are equally troubling because when your navigation system is a complex computer with thousands of components and millions of lines of software code, failure modes multiply compared to simple dedicated instruments. The touchscreens can become unresponsive, requiring reboots at inconvenient moments. The software can crash, leaving you temporarily without navigation capabilities. Number 7. Electric winches everywhere. The 7th feature ruining sailboats is electric winches installed everywhere to provide convenience that comes at the cost of complexity, expense, and reliability that traditional manual systems delivered without creating the failure points that electric systems introduce. Traditional sailboat winches were manual, purely mechanical devices using gear reduction to multiply the force sailors could apply to lines controlling sails and other critical boat functions. The manual winches were simple, reliable, and essentially maintenance-free over decades of service. They required no electrical power, created no failure points beyond the mechanical components that could last decades with minimal maintenance, and could be serviced with basic tools when they eventually needed attention after years of hard use. Electric winches provide the convenience of push-button sail handling, but add motors, wiring, switches, control systems, and circuit breakers that create multiple failure points, where the system can break down and leave you unable to handle sails until repairs are made. The motors require maintenance, with brushes that wear and need replacement, bearings that fail, and internal components that corrode despite sealing that's never perfect against saltwater intrusion. The problems compound because electric winches encourage installations that compromise safety and seamanship in ways that experienced sailors recognize as dangerous. When you're grinding a halyard manually, you feel when something is wrong, when a sail is flogging and creating excessive loads, when a line is binding somewhere in the system, when you're approaching the limits of what the rig can safely handle before something breaks. Electric winches eliminate this feedback, allowing inexperienced sailors to load systems beyond safe limits without realizing what they're doing until something breaks. A shackle fails, a fitting pulls out of the deck, a halyard parts under loads that manual winching would have warned you were excessive. The maintenance requirements for electric winches are substantial compared to manual versions that could operate for decades with nothing more than occasional lubrication. The complexity means that failures require specialized knowledge and parts that may not be available in remote locations where cruising sailors often find themselves. Number 6. Plastic through hulls. The sixth mistake ruining modern sailboats is plastic through hulls replacing traditional bronze fittings that have served boats reliably for over a century without the failure modes that plastic introduces. Through hulls are the fittings that penetrate the hull below the waterline for raw water intakes, serving engine cooling and galley sinks, discharge outlets for heads and sinks, and depth sounder transducers that provide critical navigation information. Traditional through hulls used bronze because bronze resists corrosion in saltwater environments that destroy lesser materials and provides strength that keeps fittings from failing even when impacted by debris or subjected to stresses that boats experience. Bronze through hulls installed properly can last the life of the boat, requiring only occasional maintenance. Plastic through hulls save manufacturers a few dollars per fitting, but create failure risks that should terrify anyone who understands that through hull failure means water pouring into the boat with the potential to sink it if not addressed immediately. The plastic degrades from ultraviolet exposure even though it's below the waterline, because UV radiation penetrates several feet into clear water, attacking the plastic molecular structure. The plastic becomes brittle over years of UV exposure, developing stress cracks that can propagate suddenly into catastrophic failure. The plastic threads strip more easily than bronze when fittings are serviced, with the softer plastic unable to withstand the torque that bronze threads handle routinely. The lower strength means plastic through hulls are more vulnerable to impact damage from debris floating in harbors, or from grounding incidents that bronze through hulls would survive without damage. The surveyors documenting plastic through hulls note them as items requiring eventual replacement and recommend that buyers budget for upgrading to proper bronze fittings. The used boat market reflects this understanding, with buyers discounting boats equipped with plastic through hulls or demanding that sellers replace them with bronze before closing the sale. Number 5. Lightweight hull materials. The fifth problem ruining modern sailboats is lightweight hull materials that manufacturers use to reduce costs and improve performance claims, but compromise the structural integrity that makes boats last for decades rather than years. Traditional fiberglass construction used solid laminates of woven roving and mat, saturated with polyester or epoxy resin, creating thick hulls that were heavy but incredibly strong and durable. The solid laminates were overbuilt by modern standards, using more material than engineering calculations suggested was strictly necessary. But that extra material provided safety margin that allowed boats to survive conditions beyond their design parameters, and abuse beyond what careful owners would inflict. Modern construction increasingly uses sandwich cores, foam stringers, and other techniques, reducing weight by replacing solid fiberglass with lighter materials. The marketing emphasizes improved performance from reduced weight and better stiffness to weight ratios that sound impressive to buyers who don't understand the compromises being made. The problems emerge gradually as these lightweight structures experience the constant flexing, impact, and stress that boats endure. The foam cores can absorb water if the outer skin is damaged, adding weight while reducing structural strength. The core materials can separate from the skins through delamination, creating voids that weaken the structure. The lightweight construction that seemed adequate when new develops problems after years of use, that solid construction would have shrugged off, creating boats that feel tired and worn after a decade, when traditional construction would still feel solid after 3 decades. The deck flexes when you walk on it, the hull panels oil can when you press on them. The repairs are difficult and expensive because fixing delamination or waterlogged cores requires cutting away large sections of the structure, removing damaged core material, drying everything thoroughly, installing new core, and laminating new skins over the repair. The costs can reach tens of thousands of dollars for major structural repairs. Number 4. Digital switching systems. The fourth disaster ruining modern sailboats is digital switching systems that manufacturers install to impress buyers with modern technology, but create nightmares when they inevitably fail. Traditional sailboat electrical systems used simple mechanical switches and circuit breakers that could be understood, maintained, and repaired by anyone with basic electrical knowledge and a multimeter. You could trace circuits visually by following wires from switches to loads, test voltage at any point in the system with basic tools, and replace failed components with standard parts available at any marine supplier. The systems were robust because they were simple, with each switch directly controlling its circuit. The systems failed gracefully. When a switch broke, that circuit stopped working, but everything else continued normally. Digital switching replaces all of this with computer-controlled systems, where touch screens or smartphone apps send commands to central controllers that operate relays, which actually switch the loads. The manufacturers market this as convenience and sophistication, showing buyers controlling all their boat systems from a tablet. The reality is that digital switching creates single points of failure, where the loss of one component can disable multiple systems simultaneously. When the main controller fails, and it will fail, because electronics always fail eventually in the harsh marine environment, you cannot simply bypass it and wire around the problem. The system becomes an unfixable brick, requiring complete replacement at costs of thousands of dollars, assuming replacement parts are even available for systems that may be obsolete within 5 years of installation. The proprietary nature means you're locked into one manufacturer who can charge whatever they want because there are no alternatives. The used boat buyers see digital switching and walk away because they understand the risks. The survey reports note these systems as potential problems, warning that failure will require expensive specialist repairs. The boats equipped with digital switching sight on the market while buyers choose boats with traditional electrical systems. Number 3. Iron keels. The third problem ruining modern sailboats is iron keels that builders use because iron is cheaper than lead, but creates problems that devastate resale values and eventually threaten the structural integrity of the entire boat. Traditional sailboat keels used lead because lead doesn't rust or corrode in salt water, provides maximum weight and minimum volume due to its exceptional density, and can be formed into shapes optimized for hydrodynamic performance. Iron keels save manufacturers money during construction. Iron costs significantly less per pound than lead. The savings can be substantial on larger boats, where keels might weigh 8,000 or 10,000 pounds, creating savings of thousands of dollars per boat that manufacturers can use to increase profit margins. But iron keels create time bombs that eventually destroy value through problems that emerge gradually over years as the iron rusts despite paint and protective coatings, because salt water is incredibly corrosive. The rust expands as iron oxidizes, creating stresses that crack the keel-to-hull joint and allow water intrusion into the bilge. The structural integrity deteriorates as rust eats away at the iron from the inside out, reducing the keel's strength and creating voids where solid iron should be providing ballast. The deterioration eventually reaches the point where keel failure becomes possible, the terrifying scenario where the entire keel separates from the hull, leaving the boat uncontrollable and likely to capsize. The surveyors who inspect boats before purchase know to look for iron keels and warn buyers about the problems they create with survey reports that document rust staining around keel bolts, moisture readings indicating water intrusion, and the recommendation that iron keels be considered consumable items requiring eventual replacement at costs that can exceed 30% of the boat's value. The buyers looking at used sailboats see iron keels in survey reports and walk away. The boats with iron keels sit on the market for months or years, with asking prices dropping steadily as sellers discover that what seemed like a minor detail when buying new has become a deal breaker. Number 2. Open-plan interiors. The second feature destroying modern sailboats is open-plan interiors that look spacious and inviting at boat shows, but become dangerous at sea due to poor bracing. Traditional sailboat interiors featured substantial bulkheads, dividing the cabin into separate compartments. These bulkheads weren't just room dividers. They were structural elements, bracing the hull against the tremendous loads generated when sailing hard. The forces involved are staggering. Thousands of pounds trying to bend and twist the hull as waves push from different directions simultaneously, and the rig loads the deck from above. The bulkheads transfer these loads through the structure, preventing the hull from flexing excessively and developing stress cracks. Modern builders eliminate bulkheads to create open interiors that photograph beautifully and impress buyers who spend 5 minutes aboard at boat shows. The marketing emphasizes spaciousness and visibility, showing couples preparing meals while talking to friends sitting across an open interior. What the brochures don't mention is that removing bulkheads eliminates critical structural support that the hull needs, making the hull weaker precisely when strength matters most. The hull panels flex more without bulkhead support, and stress concentrates around chain plates and other hard points. The lack of interior bracing also creates serious safety hazards when the boat is heeling and pitching. In traditional layouts, the bulkheads provided natural barriers that prevented crew from being thrown across the cabin during sudden lurches. In open-plan interiors, There's nothing to stop you from being hurled the entire width of the boat if you lose your grip, creating injury potential that should terrify anyone who's experienced genuine offshore conditions. A crew member thrown from one side to the other can travel 10 feet or more before impacting the opposite hull, generating forces sufficient to break bones or cause head injuries. Number 1. Frameless windows. The number one feature ruining modern sailboats is frameless windows that represent the perfect example of style over substance. Builders marketing sleek modern design while sacrificing durability and repairability. The manufacturers emphasize unobstructed views and contemporary styling that makes traditional framed ports look dated. The reality is that frameless windows represented cost-cutting, disguised as innovation. Traditional framed ports used heavy bronze or stainless steel frames through-bolted to the cabin structure with substantial backing plates, creating watertight seals that could be maintained indefinitely. The frames provided structural support that helped the cabin withstand the flexing and stress that sailboats experience, with the metal frames tying cabin sides together. The through-bolted installation meant frames could be removed and reinstalled for maintenance. Frameless windows eliminated the frames and used adhesive to bond acrylic or glass directly to fiberglass cabin structures, creating clean lines that looked impressive but sacrificed durability. The adhesive bonds were strong initially but were not permanent or maintainable the way through-bolted frames were. The problems with frameless windows emerged gradually over years of exposure to sun, salt, and constant flexing. The leaks start small, a few drops during rain, but worsen progressively as the bonds deteriorate and larger areas lose adhesion. The repairs are difficult and expensive. The entire window must be removed by cutting through the adhesive bond. The old adhesive must be completely cleaned away. New adhesive must be applied perfectly, and the window must be held in precise position while the adhesive cures over 24 hours. The cost for professional frameless window repair can reach thousands of dollars per window, and boats typically have 6 or 8 windows, meaning complete window replacement can approach the cost of a new diesel engine. The structural weakness is equally serious. The framed ports contributed to cabin strength by tying the cabin sides together through the frame structure. Frameless windows provide no structural support, meaning the cabin sides flex more and stress concentrates around the window edges, where cracks can develop in the fiberglass itself. The used boat market reflects understanding of these problems, with buyers seeing frameless windows and immediately calculating thousands of dollars in eventual repair costs. The boats with frameless windows sit on the market longer and sell for less when transactions finally close. These 12 modern features prove that progress in sailboat design has often moved backwards, sacrificing the durability, simplicity, and seaworthiness that made classic designs valuable. The buyers who understand sailing avoid these features and choose proven designs with quality construction and simple systems. Which of these features have you encountered? Share your experience in the comments. If you value honest talk about sailboats, subscribe for more maritime documentaries. This conversation is just beginning.